All right, this is Chem lesson number 4. Um, and we understand atoms are tiny. Atoms are almost all empty space. Atoms are made of protons, neutrons, and electrons. And we know a little bit about the protons and electrons and neutrons. Protons and neutrons are about 2,000 times bigger than electrons. And they sit in the nucleus of an atom. And whizzing around them at incredible speed, unimaginably high speed, making insane amounts of trips around that are these negatively charged little electrons. They're like little gnats or mosquitoes flying around, but insanely fast. And that's the basic shape of an electron. Now, given that, you can, let me try to make sure I don't glare. I don't know why I have glare on this. But you can draw the atoms. Now, people tend to discount this, but atom number 1 is your first atom. It's called atom number 1 because it has 1 proton. So I'm going to draw a hydrogen atom. It'll look like this. 1 proton, and it'll have 1 electron, like that. And the electron will be negative, and the proton will be positive. Okay? That's a proton atom. Simple. Proton atom is actually the simplest atom. That's all there is. Now I'm going to draw atom number 2, which I should do. I go here, and here's atom number 2, helium. Now, helium has 2 protons, so I'm going to have to erase this, and I'll start all over. And here's my goal, the objective for this lesson. Here's what we're trying to accomplish. I want anyone in here to be able to draw the first 20 atoms. So atom number 2 has 2 protons. And it has 2 electrons. Now the electrons are negative, so I'm going to stick 1 there and 1 down there. They kind of spread out a little bit because they're like negative, you know, and that's a helium. Now helium normally has 2 neutrons, which I'll put the little neutrons right here. I'll just put a 2 in. Now this is not a real picture of what helium looks like, but it isn't that bad. People tend to discount it and say how wrong it is, and I showed earlier how it's very wrong. But look, does that look like my fingers? If you just had that, that would be an image of my fingers. Guess what? We don't see the real atoms. We're just trying to figure out some things about them. So for our purposes, we'll say that's good enough. Good enough for high school, good enough for middle school to teach, good enough for probably the first couple years of college of what a helium atom looks like. And it will give us some power to predict some things. Now, let's draw atom number 3. What's atom number 3? Atom number 3 is the one with number 3 right there. 3 protons. Remember, the protons are what makes the atom what it is. They're the most important thing. So I'll draw lithium. Has 3 protons. 3 protons. And I hate having this tiny dry erase board, but there. Now, it has 3 electrons because it has 3 protons. Why is that? Where's Sear at? Sear! Get in here. So, it has 3 protons. It has 3 electrons because it has 3 protons, because you have 3 positive protons right here. 3 positive charges. So it's going to have to balance out, because if it didn't, then it would be magnetic, stick to something. So I put, watch, this is why the periodic table is so wonderful. I have 2 electrons. First 2, so I'll go here, my electron here. Actually, I should have done that smaller. 1 here, so my second electron. But the first shell is kind of small and tight, and these negative things are whizzing around so fast, bumping into each other, it's hard for another electron to get there. So it tends to go to a third shell, or second shell rather, and there'll be an electron there. So there's an electron, there's an electron, and there's an electron. That is basically what a lithium looks like. Lithium, which my shower curtain that I put on the wall doesn't have their mass. Lithium tends to have an atomic mass of 7. If 3 of those 7 are protons, then 4 are neutrons, and so it tends to look like that. And that's not a bad representation of lithium. Li, lithium. Yeah.
Does, like, this number, does it mean how many, like, atoms are in it, or how many
protons are in it?
Yeah, does it mean how many protons are in it, or does it mean it's, like, the 5th,
element?
Yeah.
Both.
Both.
That number 5 means it has 5 protons, and it is atom number 5. Look, here's how it's set up. Atom number 5, 1, 2, 3, 4, 5, has 5 protons. Atom number 6 has 6 protons. Atom number 7 has 7 protons. They could not have made this easier. Not only that...
But then what would they do if there was, like, 2 different elements that had 49?
Well, what would they do if they had 2 different numbers which were each numbered 49? That'd be the same. That would be, if you had 2 atoms with 49 protons, it'd be 2 of this same atom. Indium, which I was not that even familiar with that one. So yeah, if they had 2 atoms with 14 protons, it'd be 2 atoms of silicon. If it had 2 atoms of 80 elements, it'd be 2 atoms of mercury. If you took mercury and you had 81, then it'd be thallium. And if it had 82, it'd be lead. The protons make it what it is. You cannot change the proton number without changing the atom.
And mercury is liquid metal, right?
Yep. Which just
it melts at a super
low temperature. Now here's another thing that's cool about the periodic table. Look here. Lithium is in row number 2, so it has 2 shells. This is in row number 3. What do you think it'll have?
3 shells.
What do you think this in row number 4?
4.
Yeah. And it sort of goes in their levels, energy levels. And when you go to do SPD...
So a hydrogen atom is kind of like the most simplest atom.
Yep, it is definitely. Now we'll draw atom number 4. Very easy. We'll draw atom number 4. Atom number 4 is beryllium. It really doesn't matter what it is.
Dad, what's a lithium battery?
It uses a lithium metal instead of like the lead. You just need, to make a battery, you have to have a couple different metals because you have to have a gradient between them, a potential difference. Let me look at beryllium. Beryllium, Be, has 4 protons, and it's going to have 4 electrons, but those electrons are going to be, the first shell, look here, it's pretty neat. The first shell only holds 2. Look, 1, 2. The second shell will hold 8. How do you know that? You don't have to memorize it. 1, 2. Say it again.
You just count them.
You just count. 1, 2, 3, 4, 5, 6, 7, 8. Third shell, how many does it hold?
1, 2, 8.
Hey, you're smart. Fourth shell. When I get to these big atoms, what is it? How many does it hold?
9, 10, 18.
You're right. And now, when I get to here, they've actually, since you never use these, I've actually cut out on my wall. When I teach, I will show you. They actually cut these out, and I make a proper periodic table where I cut here, 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 and I insert these. Because you see 56, and then it goes 57. This should be here. But that would make your periodic table really long and skinny and not fit in a book page good. And these are rarer than gold. You never see them anyway. So they just kind of...
What are they like?
They're called the lanthanide series and actinides. And they're elements. That's an atom with 60 protons.
It says rare earth metals in the box above thing. So are they
Where?
all metals?
Yes. And that goes on to something else. We'll tell the group. Let me see. Okay, I got some time to this. Let's draw a couple more atoms, because our objective today is for you to be able, this objective for today's lesson is for you to be able to draw. I can point to any of the first 20 atoms and you can draw them. And you're not really drawing them how they look, because remember, I showed you, let me see if I... remember, I showed you they really don't look like what we're drawing. They look more like this, and they're all kinds of weird clouds. Oh man, I hate that this broken computer's a touch screen. Well, there's a Wikipedia page that they kind of have different shapes, but those are the clouds. And when they say a cloud, because see, one atom moving around a million times is a cloud. So they have these clouds of electrons around these nuclei, these balls of protons and neutrons, which are just quarks and up and down quarks stuck together. That makes a shape. But for our purposes, to tell what an atom is going to do, this works pretty good, and to show how things to go together. So I'm drawing my atoms, and you draw the first 20. I'm drawing the beryllium. It's atom number 4. There's the 4 there. It's in the second row, so that means it's going to have 2 in its last shell. It's in row 2, second column rather. So I have electron, 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 and I have 5 neutrons because its atomic mass is 9, and the mass is what the protons and neutrons add up together. So this is beryllium. It looks like this. I'll draw this little electron because I don't know how good these will be on a YouTube video. And remember, these electrons are whizzing around. Zzz, crazy. I have to draw them somewhere, but it would be like air molecules, only a million billion times faster. And these are kind of sitting in the center, and that's the atom. And it's moving. It's insane to think that the atoms in this board are moving. Can't see them move. You know, just like if you were in an airplane miles above the ocean, it would look like a flat blue screen. But if you got to the ocean, you see all the waves crashing around and stuff. Well, that's like an atom. You're so much bigger than an atom, and you're a billion, trillion times bigger to an atom than you are to the ocean a mile above it. It would be like looking, you know, if you looked at a star, if you look at our sun, it looks like the sun. But there's nuclear explosions going on its surface and things. Same with an atom. As you get bigger and bigger, all the movement you can't see. So an atom is moving, an atom is small, an atom is made of 3 parts, protons, neutrons, and electrons, and an atom, everything on Earth is made of atoms, and these atoms are arranged on a beautiful thing called the periodic table of elements. And it's the cookbook, the ingredient package of everything you see. So that is beryllium. Let's see if you can draw boron. Try it, and I'll show you how to draw it. It's very simple. Simple.
Daddy.
You want to draw it? Get up here, boy.
No, I have a question.
What?
So you said the rows are, so if it's in row 2,
Yeah.
Dad, you said rows are going this way and columns are going this way.
Rows go sideways, columns go up and down, right?
So do the columns have anything to do with, because the rows have, if it's in row 2, it has 2 shells.
Yep.
What does the column have anything to do with it like that?
Yes.
What does it have to do?
I'll show you. Let's draw boron. Number 5. 5 has, how many protons? Here's a good question, Zaylin. How many protons are in atom number 5?
5.
Good man, you're so smart. How many electrons? Since electrons are negative and protons are positive, if there are 5 protons in atom number 5, how many electrons in atom number 5? How many? How many?
5.
5. So, and I draw these little dots. How many can fit in the first shell?
2.
Right, we know that because
Dad,
1,
because-
2, there's only 2 spots. If you ever forget that, look at your periodic table. If you have a periodic table, every test I give you, you can have a periodic table.
Dad,
It's your greatest cheat sheet in the world.
in every shell, is there only 2 electrons, or can there be more, or can there be
Look, the first stop. The first shell can hold how many, Zaylin?
1, 2,
2. How many can fit in the second shell?
3,
How many? How many can fit in this second shell?
8,
8. How many can fit in the third shell?
8,
Right? How many can fit in the fourth shell?
18,
Right? In the fifth shell. And now the 6th shell, you actually have to add up these down here. But it doesn't really follow. Now, as it gets bigger, it tends to get more complicated. You can't follow. They don't follow real perfect as they get bigger. Do you know why?
Why?
I'll tell you why. Because what are the electrons charged?
Negative.
Negative.
Don't
So-
they want to be
so I have a
completely
negative.
opposite from each
Hang
other,
on.
though?
Then I have a negative. Then I have a 3rd shell, and I have a negative. And then I have a 4th shell, and I have a negative. So what if I have a negative magnet and a negative magnet and a negative magnet and a negative magnet, and a positive here? This one has to. Is it going to be attracted to the positive, or is it going to be repelled by all those negatives?
Repelled by the negative.
So now these start to float out, and they can actually sometimes it's like, oh, I'll just skip down here. So they start to not follow as good of rules as they get bigger. Kind of like you know how the English language has these grammar rules, but then they break them a lot. Sort of like that. So as the atom gets bigger, it gets a little less simple, and they don't follow the rules. But let's go back to this. So that's why I just say, let's just make sure we draw the first 20. And remember, quit playing around. Remember, this isn't really the way atoms look, is it? This is just a representation. It's like, it's kind of nice to have it. So if I draw atom, let me see what time I am. Oh, heck, I got to get out of here. Okay, that's rudimentary drawing of atoms, lesson 4. We'll get to more later.